We'll start soon. And the first thing, we'll start today with the non-parametric test. And in that, once that is over, we'll be talking something about the which topic you have taken and also about some of the problems you have. The non-parametric test, the advantage is even with a very small sample size, you can work with that. Particularly the clinician, when they don't have a large sample size, when the sample doesn't follow the normal distribution, there is alternative distribution. For that purpose, we have non-parametric tests. They are a little bit looks difficult, but for the purpose of the clinician, it is very important. If there are only few events, it should be utilized. Once that is over, then we'll be starting the your topic, your population which you're going to take, the sample size, sampling technique, etc. And the the words are a bit unfamiliar, but the tests are relatively easy. Now, the Kruskal-Wallis H test is a non-parent procedure that can be used to compare more than two populations in a completely randomized design. What does it mean? You have, let's say, three or four or five population you want to compare. When you compare four or five population, essentially you are comparing samples. Suppose you want to compare five countries. Naturally, you are not going to take the whole country. You are going to take a sample of each country and then you will compare. In case of, let's say you have you are working in the wards and you are using five different techniques and you have only 10 patients or 15 patients in each group and you want to find out which method is better. At that time, this Kruskal-Wallis test will be useful. And it says that all N1 plus N2, NK measurements are jointly ranked treat as a one large samples. There are three, four, five groups, but then you combine them that as if it is only one sample. In one is there is a 7%, other 8%, 5% together. But when you do the ranking, you make all the to take all the together and then rank. So essentially, the Kruskal-Wallis edge test is useful when you have smaller samples, multiple samples to compare. And we'll take an example. We use the sum of the ranks of the k samples. For example, if you are having a seven samples, seven population to compare, right? Then you are going to use the ranks, right? Sum. For each sample, you have a the sum, and then you try to compare the distribution. This example will make it very clear. Rank the total measurement in all case samples from 1 to n. Tied observation are assigned average of ranks they would have gotten if not tied. In this case, see rank sum of ith sample I is equal to 1, 2 up to k is a question of making the tied observations and the ultimately when you want to compare the h value just like we find out the z value, p value, or in case of a chi-square value like this, we talk about the h value over here. And the moment I go for the example, it will be clear this equation you are not supposed to remember, you are supposed to use it. Right? And hypothesis, the k distributions are identical versus at least one distribution is different. So it will say that if out of five population, if one population differs, or I say out of five samples, if one sample differs, it will show that yes, there is a difference. Kruskal wall is H, just like a Z or chi-square. Here we are using H. And when H0 is true, the test has H has an approximate chi-square distribution of degree of freedom is equal to K minus 1. So, if there are, K is the number of samples. If there are 5 samples, degree of freedom will be 4. A right tail rejection region or p-value based on chi-square distribution. So, chi-square table, if you look at a different, the degree of freedom and a different probability, the chi-square value will differ. As chi-square value is increasing, p-value will decrease, just like a z table. If z is more than 2, probability is less than 0.05. If z is 3, 4, 5, p-value still will be lower. Similarly, in this H also, it will follow something like chi-square distribution. Now, this is the one of the uh, example which you can relate with yourself. Here it's a student. You can use the word the patient or other employees, etc. 4 groups of students were randomly assigned to be taught with 4 different techniques. Group number 1, 2, 3, 4, all are taught with a different techniques, and their achievement test scores were recorded. Are the distribution of test scores the same or do they differ in location? So let's say here the group number 1 got marks 65, 87, 73, 78. Group number 2 got 75, 60 like this, and group 3 and group 4. So if the figure are given directly only 4% in each group, it is very difficult to find out is this significantly different or not. But with our test, we will be able to do that. Now look at the first step. Total number, total number of students are 16. So the total uh, 16 students are having the marks attached with that. So into bracket, we write down the score. So the lowest is given 59 as a 1, 622 as a 2. Then comes 65, that is given rank 3. Then comes the 67, so 4. So similarly, we are going higher. Right? 5, then 6, 7, then the 8, the 9, here 79, and 10 is over here, right? So this is the rank is given as if all these 16 observations are one and the same, starting from the lowest to the highest. If you look, the 94 is the highest, so it is given as a 16. Some of you might feel that if both are having the same marks, it's not that everybody will have a different marks. Then also you can uh, this, give that number, the same number to both the participants, right? 15 plus 15, like you can give it. Now, TI, this T1, T2, T3, T4, this is a total of rank of first, total of rank of second sample, third sample, fourth sample. So TI is 31, 35, 15, and 15. So what does it suggest? That these people are having higher marks, these people are having lower marks. That seemingly you can see. But the test will tell you whether this difference is significant or not. Null hypothesis that distribution of the scores are the same, and alternative hypothesis that distribution differ in the location. Now, how do we make it total? Now, H is equal to 12 is a constant figure already given in the equation. Like n plus 1, n is total number is 16, and n plus 1 will be 17. And the TI square, that is a 31, 35, 15, and 55 square. Ni means number of samples. Number of samples are 4. It is not sample size, it's the number of samples, or you can say number of set of population from which the samples were taken. And 3 is a constant, n plus 1, that is 17. So answer is 8.96. That is H status 6. And then this 8.96, we need to interpret what does it mean. Just like Z is equal to is more than 2, or Z is a 3, 4, like that. H is 8.96. That means for a right-tailed chi-square test, alpha is equal to 2.05 and degree of freedom is equal to 4 minus 1 is equal to 3. So reject H0 if H is more than 7.81. So here we need to look at the table in which the degree of freedom is 3. It is said that we need to look at the chi-square table, right? So a degree of freedom 3, if it is less than 7.81, suppose this figure is 5, we would say that there is a no significant difference. We'll accept the null hypothesis. There is no variation. But this is 8.96. And so we reject null hypothesis and we say that there is sufficient evidence to indicate that there is a difference in test score in 4 techniques. Now, out of 4, which one is more important? Which one is likely to be more useful? That you can take a subset and then find out, or seemingly you can say that the 55 was better. You can say over here, this 55, right? That could be better, or even this 15 could be the lowest. So to differentiate between any two, for that purpose, you can again go for the H test and then find out whether it is significant or not. But if this says that it is homogeneous, then there is no point in comparing these two, right? So seemingly over here, you can say that either 15 or 55, that plays a role. This 31 and 35, seemingly, they are almost similar. So you can say that this method 4 seems to be more successful. Method 3 seems to be the least successful. So, in the key concept is these methods can be used when the data cannot be measured on a quantitative scale, or when the numerical scale of measurement is arbitrarily set by the researcher, or when the parametric assumptions such as normative or constant variance are seriously violated. So basically, last thing, you don't have the thousands of patients to compare over various modalities. In case suppose you are using your anesthesia technique, right? You have 3 techniques to compare and you have only 10 patient or 8 patient in all the 3 groups, then naturally you will not be able to uh, do the analysis with F test, right? Though in that case, will be a better. And this is the equation which we can use it. There could be a quick question as you can go through this slides and try to do this kind of analysis at your level. It is very simple. Kruskal-Wallis H test, you utilize it when you have the multiple groups and very small sample size, right? And I think this is a time where you should write down that this Kruskal-Wallis test, you will be utilizing particular field. You can name a single field and I will tell you how we can utilize this, right? Any question? We go for another test. This man Whitney test and Wilcoxon sign rank test. 2 tests we are going to tell. It was taught to me by Dr. Divakar Sharma and is a uh, very good statistician. Right? And let me move further. So, Kruskal-Wallis test, you should write down only one thing that when you have multiple the samples or multiple population and you have a small sample size and the data is in terms of, let's say, the marks or some kinds of the ranking method, at that time you can use this, right? But if it is something like plus or minus, positive, negative, at that time you cannot use that. In Man-Whitney U test and Wilcoxon sign rank test, we'll see now. First, we see Man-Whitney U test, right? It is also known as Wilcoxon rank sum test, but let's use Man-Whitney test. It is used to compare two groups by ranks. Two groups we are comparing, and it is a non-parametric test used to determine whether two samples of ordinal rank data differs or not. Two data set is given to you, and whether it differs or not. It is a non-parametric test equivalent to conducting an independent t-test comparing two groups on a normally distributed continuous variable. Suppose you have the 30 students on one side, 30 on other side, and you want to compare their marks, or your 100 students, you're comparing their the heart rate, etc. But in instead of that, if you have the rank data, right? For example, mild, moderate, severe, you are ranked like 1, 2, 3, etc. At that time, on a small sample size, you need to use man-Whitney test. We'll see the procedure to example to make it more clear. Samples are randomly selected from two independent population and representative of population. That is assumption. So whole game of statistics is basically to talk about population based on a sample. If you are going to cover the whole population and you want to compare with the other whole population, of course we will use statistics, but it is least likely that you compare the whole population. So is it basically how do you choose a sample and how do you compare the with the population or with other two population by taking two samples. It requires two sets of data. This need not be paired, nor need they be normally distributed, or need there be equal numbers in set. If there could be 7% on one side, 10% on the other side, that is also possible. Unlike parity test, in parity test, you should have a same numbers. Now let us see how we are doing it. So let us see there are two data sets
बताया
available.
आगे
Yeah. And on one
अरे
side,
अभी मेरा
you have,
व्हाट्सएप पे है
yeah, what do you want to ask? You want to ask something?
अरे बोलेगा मेरा भी मीटिंग चल रहा है
To
जो
ask
मीटिंग पे
something?
है ठीक है बाद में सामान रख दीजिए यहाँ पे है नहीं तो अ, रख दीजिए हम पहुंचवा देंगे बोल देंगे बॉस को आके ले जाएगा
If you want to ask a question, you can unmute and ask me. So basically, you have very small sample, two samples are there. The five, four, these are the rings in one data set, others data set. And we want to find out whether these two small samples, right? They are chosen maybe from some population, but whether there is any significant difference with these two or not. For that, we are going ahead. Rank all data into ascending order and then recode the data set replacing raw data with the ranks. That means as if it is a together, you are giving a rank and then rank you are going to compare. So just look at this, how it is given a rank. Right? So you can see that there are total 13 observations. And all these 13 observations are ranked from 1 to 13. This is clear. This number 1 came twice. So automatically 1 over here, 2 over here. Then the 3, then the 4, 5, like this. If they are the same one, still they are given ascending numbers. But then we'll see the next stage that will be harmonizing the ranks. Harmonizing means if we have same value, then we take an average. Look at this. Probably I need to make it a small. Now you'll be able to see better. See, here the one was given rank 1, another one was given 2. But this average, if you take it, the rank should be 1.5, 1.5. Similarly, if you look at the 4, then it is a 10, 9, 8. 8 and 9, 17 and 10, 27. So 27 and you divide it by 3. So it is 8.5 because this is also there. Another the 7. So basically 9, 8, 17 plus 7, that is 24. 17 plus 7, 24 plus 10, 34. So 34 divided by 4. That will be 8.5, 8.5, 8.5, 8.4. So all the 4 are given similar. So if you have understood this much, then almost the work is done. Why do we do like this? Because we have very small data. We are combining in a series of data and we are giving the ranks to it. And because the value are the same, rank should be the same. So we take an average of that rank and assign that rank to each value. So this is how it is harmonized. And the next stage would be once the data are ranked, now once most of the task is done by now. So the next thing would be add up ranks for each column called Rx and Ry. This Rx and Ry, first and second. Right? Optional but a good check is Rx plus Ry, making a total of each column, and then total number of sample size multiplied by total number of sample size plus 1 divided by 2. Now, if you look at this, it will be the same provided you have given the correct ranks. Now, when you calculate Ux and Uy, there's again a formula which we'll be looking at. This Nx is a first series, Ny is a second series, right? Like that. And Rx is the total, Ry is another total. Once you have this Ux and Uy, whatever is the smaller, that value you should be taking. Take the smaller of these two values and look up in the tables. And if U is less than critical value, reject null hypothesis. So U value convert into the Z score is also possible. If you don't have the table, you can convert with a Z score. Looks a bit tedious, but is not that difficult, right? I'm going back just to summarize that what we have done so far. So initially you have two small samples where you have given the rank, like rank in recovery, rank in, for example, the first pain in the various patients, like this. And then we have given a rank, then we harmonize the data, and then we'll be calculating if you want to convert into Z score, there's also formula. Now, actual calculation is given over here, right? So RX 67 is total of this, and RY is total of this. And the UX is over here, and UI is over here, right? So 3 and 20, 39. If you want to look at the formula of UX and UI, it is already given. Now, out of this 3 and 39, we will be using 3. So, when we convert into Z, it comes to around 2.57. That means it is statistically significant because Z is more than 2. We can say that it is statistically significant. So, this is we have seen about the Mann-Whitney test. So, if you are supposed to understand Mann-Whitney test, where there are small two samples you want to compare, for that it is useful. And this will be more useful to the clinicians. Any question on this? So files are given to you, go through it. Any question? Again, we can go through it. Next is Wilkinson sign rank test. This is utilized when you have positive, negative, both the things are there. Somebody will increase the pain, somebody will decrease the pain. At that time, we need to use this test. We'll see the example. The Wilkinson sign rank test is the non-parametric test equivalent to the dependent t-test. When we are going for, let's say, the pair t-test, right? Like this, when there is a data in the pair, we can use this Wilkinson sign rank test. It is used when we wish to compare two sets of score that come from the same participant before and after surgery, before and after diet therapy, before and after physiotherapy. If you want to compare this in the same patients, that it will be useful. Samples are randomly selected and representative of the population. Two groups should be matched and data is ordinal. W plus means you make a positive differences and W minus sum of ranks for negative difference. Because pain may increase, pain may decrease. Pulse may increase, pulse may decrease. Weight may increase, weight may decrease. Both the things will nullify each other. So in this case, what we are doing, positive and negative, they are considered specially that way. And then we'll apply whether there's a real difference or not. Calculate W as the smaller of these two rank sums. Whatever is smaller, that total we are considering. Just like in U, what we consider the smaller UX and UI, smaller one we considered. So let us take an example, and this example, it may take 2 minutes, but very useful for clinician to evaluate their own data, right? A pain researcher is interested in finding the methods to reduce the lower back pain in individuals without having to use drugs. Person says that without using drug, with acupuncture, I'll be able to reduce the back pain. Now let us see whether acupuncture was useful or not. To investigate this, the researcher recruits 10 participants to their study. At the beginning of the study, the researcher asks the participant to rate their back pain on a scale of 1 to 10, with the 10 indicating the greatest level of pain. So now it says that 10 patients are there, first patient, second, third, before acupuncture and after acupuncture. Patient will be scoring themselves. Their perception will be there. But then we want to find out whether the acupuncture was effective or not, or only it was some random effect, right? That we will be able to find out. After 2 weeks, he asked again to indicate the level of back pain on a same scale. He wishes to understand whether the participant pain levels change after they had undergone the acupuncture. Now, instead of 10 patients, you can take 10 students, 15 students or 15 patients. You can compare for your input whether their memory improved or not, whether their hemoglobin level increased or not, whether their weight was reduced or not. All this thing can be possible, right? Now look at this data carefully. This is a very simple and it can be done easily. So the first patient rating before therapy was pain was a level 5 and after 4 weeks pain level was 2. Similar second patient 8, 4, 7, 5. But the fourth patient you can see the initially the patient the pain was 4 but it has increased to 7. Rest of the time improved. This patient again increased pain. This also increased. In 3 patient pain was increased. So they have 3 minus signs, right? And one remain the same. So not a minus, not a plus sign. So plus 5 minus 2 is a plus, 8 minus 4 is a plus, but 4 minus 7 is a minus 3. So sign is written over here. Then the actual values are written over here. Without sign, it is written over here. Sign 3, 4, 2 is absolute value is written over here. Now remember that here the absolute values are given rank 1, 2, 3, 4, like this. The rank is given over here. And then the again, if you look at over here, this is an average of the rank. This is a 4, this is a 5, this is a 6, and this is a 7. If you look at the 3, 7 plus 6, 13 plus 5, 18, 18 plus 4, that is 22. 22 divided by 4, that is 5.5. So that is harmonization is done over here. Once you harmonize the rank, apply apply this sign to this rank, and then ultimately you will get rank of the sign. And then we'll move further to find out whether the difference was statistically significant or not. Ultimately, we want to use statistics. Why do we want to use? To find out whether the acupuncture was actually useful or not. Or what layperson will say that out of 10, 7% has improved a lot, a significant 70% is the result. Oh, it's wonderful. But when we go statistically to find out whether it is significant or not, we'll find in the next few stage. Now, the test statistic W plus and W minus, right? So W plus is 33 and W is minus 12. So minus this 12, we are going to use it. You can see over here, you make a total over here, right? 5.5 plus 8.5 plus 2.5 plus 5.5, like this. And you make a total of minus 1, 5.5 plus 1, 6.5, and 5.5, right? Is 12. So here is a W plus and W minus. We are utilizing whichever is smaller. So this 12 we are going to use. The test statistics W is equal to 10 and the critical value from the table is 8 for a two-tailed p-value of 0.05. I repeat this. See, the table value is very important to look at the table. The critical value says 8, right? And two-tailed p-value is 0.05. Now, let us see at the table carefully. Now, this is 0.05. This is 0.02, this is 0.01. Now, this is 8 over here, right? And the sample size n. Here there are observation are 10 observation. Value is 8. If it is a 5 or if it is a 3, W is 5, 3. In that case, it will be highly significant. But at 0.05, this is a 0.05. At 0.05, 8 is the level. Now, because the value is 12, it will be somewhere here over here. So p value is more than 0.05. Suppose if instead of 8, if we have a the W is 7, then it will be somewhere over here. We would have said that, yeah, it is a significant, but because it is 12, we say it is not significant. P is more than 0.05. So here, that is the other exercise if someone wants to do it, right? But we'll stop over here. I will share these files with you. You can go through it, and then the three parametric, this three non-parametric tests will be useful, especially for those who are the clinician in the group. Now, there will be a uh, three tests we have seen non-practice. I've already shared with you. Go through it, and I recommend that you try to use it in your setup with a very small samples. This can be done within 2 to 3 hours. Small study can be done, and if you utilize this statistical test, it can be published in the journals also. Now, the session is open for question answer, and then we'll be going for your study design, sample size, population, and if you have any difficulties in the AP info, I can show you how to utilize AP info. So, and one to one, I have shared with you the contact number of Mr. Kalpesh Patel, who is working with me for last 28 years, has done a lot of analysis under my guidance. So if there is any problem in installation, analysis, etc., he can guide. He cannot guide you technically, but administratively he can guide you, right? So any question? I would prefer to have at least one topic from all of you, and I would also like to have a sample size. How much sample size, or what is your population, etc. So I request all of you to write. We will have quick 5-10 minutes, and then we'll review the revisor at FE info. So let me have your topic. Also tell me which population you are going to cover and how much sample you will take and what is the sampling technique. So in sampling technique, I will go a little bit detail, and finding out sample size is very simple if you utilize the AP info sample size calculator. Anyone can come out with the topic quickly. I hope some of you have read Problem Solving for Better Health. You have lots of problems around you. And select some one out of that. This is the most interesting exercise if you do in a group of 4 to 5. You need to just write down the problems around you and which problem you are going to solve that you are supposed to do it. And I think all of you should do the analysis of why and so what. And that will give you a lot of the ideas. Uh, I think I will be showing you one exercise on that next time. But any topic you have taken, anyone, for the research purpose? You give me your profession, I will give you 10 topics. Just don't hesitate. You write your profession, I will give you the topic. Write in the chat itself. At least write down your designation or whatever you have. Say physician, right? So physician, I will tell you that the you should take a topic that number of depression cases versus duration of illness. You have that as a physician, although you are not a psychiatrist, right? But if you will find the cases in OPD having the duration of, let's say, illness 10 years, 5 years, 2 years, and short duration like cough and cold, 2 days, 5 days, 10 days, like that. And if you compare, you will find a more depression cases in the chronicity, or depressed, non-depression. You can compare the mean duration of the illness that you can compare. You can compare diabetic versus depression, or you can compare, let's say, the diet pattern, vegetarian, non-vegetarian versus the cardiology problem, non-cardiology problem. So, or between male and female, what is the difference in the mean hypertension? As far as anesthesia is concerned, you can find out the recovery time. And yeah, so a psychiatrist deal with depression, that agreed, but the every 10% of the population having depression. So this is the time that we go for interdisciplinary actions, right? Or in that, in your case, you can say the dose of antihypertensive required versus duration, right? And other thing is anesthesia recovery of the patients, right? Age affects the recovery or not. Then Puri, you counsel few patients before anesthesia. Don't counsel few patients before. Not counsel. That I don't mean that basic counsel will be there, but additional counseling if you do in subset, then you will see the effect on the recovery, or recovery complication will be less. Apprehension will be less. Something like that. Right? I have prepared a Google form to look out burnout in the faculty in my medical course. Sample size depends on this response to the Google form. Sample size doesn't depend on the response in Google form. Sample size we need to decide for that, right? Because see, is the duty of a statistician to decide how much sample size is required. Retrospectively, we cannot decide of the sample size. So let us now come with the various kinds of sampling technique. So let me again clear. We have word population and individual. Population and individual. If you remember this two word population and individual, your 10 to 15% statistics is over. If you remember the measurement variable from where you can find out mean, or characteristic variable from where you can find proportion, another 10 or 15% of statistics is learned. And then you need to find out which command you are going to use in AP info. Then another 10-15% is over. And this sample size calculation we'll learn today with a very simple formula, and that will also be very helpful. In that case, first let me clear that if you have 100 people, 100 students, for example, in your class, and you are measuring their weight, then 100 student is not the population for you. 100 weights is a population for you. Of course, their weights are related to the students. Out of this 100 weight which are written, out of that you are going to take samples. So maybe a 10 or 15 you are going to take. But when you select one weight out of that, that is individual observation as far as statistics is concerned. Because the students may have height, weight, hemoglobin, so many other criteria. But in your statistics right now, 100 weights written on your board or on your computer, that is the population for you as a statistician. And the word random means, even if you are a great teacher, you should write the word. The random means each individual within a population has an equal chance of being selected. Each individual in a population has an equal chance of being selected. Then you can tell it that it is a random sample. So if you have, let's say, 100 students, and if you want to select 10 out of that randomly, 10 to be selected out of 100 students, I repeat my question, same question we asked initially. How many such samples you can take? How many such samples you can take? Can you answer it quickly? More than 100? Yes. Anyone else? Can we have 500? Is it possible? Yes, it is possible because you can go for permutation combination, right? And you can have a formula also how many such sample you can draw it. But if I want to select 10, if by random, then we should be using random number table. That is one thing that is known as simple random sampling technique. If you have not seen simple random table, I will show you sometime simple random sample. For that simple random table you should have. You should have a Z table, T table, etc. All tables I take as my homework, will share with you so that you can utilize it. But suppose you want to do this job 10 times 10 random numbers selecting from 100, you are given a serial number 1 to 100. Then you go for random number table. In random number table, you need to take a three digits 000, or you can take a two digit, but considering 00 as 100. And random number two, you select 45, 93, something like that. There's another method. You can bring out your currency note randomly and find out last two digit. That can also be utilized if you want to go for systematic random sampling. In systematic random sampling, if you want to select 10 out of 100, then your sampling interval will be 10. If you want to select 20 individuals out of 100, 100 by 20, your sampling interval is 5. If you want to take 40 out of 1000, your sampling interval is 1000 upon 40 is 25. So first you need to find out the sampling interval, that how many what should be your sample size, and then you divide total number by sample size, you will get sampling interval. Now suppose out of 1000 you want to select 40 individuals, your sampling interval 1000 upon 40 is 25. Then you should select between 1 to 25 any random number. Suppose, let me do an exercise. If you have currency note with you right now by chance, then last two digit you can uh, read it out. In my currency note, last two digit is 01. 01 means the next one is 26. Then next one is 51. The next one is 76, like this. You are go on adding 25 and then you get to 40 numbers. But suppose last two digit is 70. So 70 exceeds 25. So 25 plus 25 is 50. So you subtract 50 out of 70. So the number is 20. So 20 plus 45 plus 70 plus 25. So 70. That series becomes a systematic random sample. This is how you can go for random sample. But then sometimes what happens that you want to uh, do the study on the diabetes. You want to include both the cases, type 1 and type 2. But you have type 1 diabetes is less number and type 2 more number. And you want to do the study on the diabetes, right? So at that time, you should do stratification, type 1, type 2. And then you can take a sample adequate from each group. That is the importance of stratification. Or sometimes in the committee, you want to cover the various castes, various religion. And some of the religious, for example, Parsis committee are very few in number. So at that time, if you go for systematic random sampling, you may be giving up, you may not be including passes in that. So at that time, you need to do stratification as per the religion. So this is important for stratification at that time. Or when you want to do study, you don't have a much time to go all over, let's say Bangalore, but you're staying in a particular ward of the Bangalore. At that time, you define your population as a particular ward. So that first step, selecting a ward, may be a purposive sampling, but further you can have a random sampling. So there could be a permutation and combination. The most frequently not understood sampling technique, though it's very important, hardly anyone is using. Suppose you have the 1,000 students for the purpose of research, you want to evaluate 1,000 students, and you have 1,000 questions. I repeat, you have 1,000 students to evaluate your 1,000 questions for the evaluation. So just think of 1,000 into 1,000, you will have 10,000 cells, 10 lakh cells for the purpose of analysis. Too much. So what you can do at that time, I repeat, you have 1,000 students, 1,000 questions. So out of 1,000 questions, you find out that what are the 50 questions which are very, very important questions, or you can select 100 most important questions, and those 100 questions can be asked to all the 1,000 students. But rest of the 900 questions, you can divide it into 90 data sets, or you can divide into, let's say, nine subsets. So nine subset means 100 each. So what will happen? 100 will be asked to all. Rest of the nine subset, you divide the total 1,000 people into nine groups, right? 110 in each group, and then give an additional set randomly. So you are asking an individual only 200 questions, but from 1,000 people, you are going to have excess of 1,000 questions. So reducing your 10 lakh data cells into only 200 into 1,000 into 2 lakh directly, right? You are reducing your workload just 20%, 80% reduction. Still, you are going to get the at least all the type of data, and you will be able to do analysis. So this is a very important to find out the sample size and how much to ask to whom. Other method is, suppose you are going to do a study of a heart disease, very interesting in the community. You have 10 lakh population. So in 10 lakh population, you are not going to do the echocardiography, the ECG will not be done on the 10 lakh population. But at least 10 lakh population, you are going to do the screening. So you'll take a pulse rate, you take a respiratory rate, which is SDR, will be taking the blood pressure, etc. But those who are having a high blood pressure or very high pulse rate, you can submit them for the purpose of the further ECG, right? Now, my question to all, very interesting in this uh, multi stage uh, multi-stage sampling technique. My question is, if I do screening by ECG in person having either chest pain, high BP, high pulse rate, my question is, do I do I need to do same in people having no such indication? This is a question. On one side, screening symptoms, etc., are there. We can do the further testing. But those who are not showing anything, should we go for the higher the investigation? Yes or no? Because the same question I will be asking whether we should be going for echocardiography or not. whether we should go in treadmill test or not, like this. So what is your answer? Yes or no? So the question is, answer is yes, but in a subsample. If you are doing, let's say, out of those showing, let's say 100,000 people are showing a particular symptoms, etc., and so you are going for high level test. So you need not take 1,000 people for high level test, but at least subsample 150 people you should be going for higher test, even if they are not indicating in case of research, because sometimes you miss the opportunity. There could be a problem without the symptoms also. So this is smaller population will give you indication whether you are on the right track or not. But in case of the invasive technique, for example, if you want, whether you want to go for, let's say, the CAT scan, for example, CT scan, or angiography, etc. For that, you may not be proceed. But for non-invasive test is concerned, you should be taking subsample for those who are not fitting to your criteria also. And the step wise when you are going, no, one step, second step, third step, etc. Or the stage wise you are going. See the two words, stepwise and stage-wise and multiphasic. There are three things together we are going to learn now. In a multi-stage sampling technique, first stage, you are screening 10 lakh population. Next stage, those 1,000, 2,000 people showing a particular thing, you are submit to another, the advanced screening test. Then to another further advanced like this. And you take a control population also, though are not showing. This way, stage wise, you are going multi-stage sampling technique, right? So that you don't spend lot of money with all kind of investigation, all the population. Second thing is, if I want to cover the whole India, I may not be able to cover whole population. So first step, I go for selecting only three or four or five states. Then in each state, three or four district. In each district, three or four taluka. If I go this stepwise, it is a multi-step sampling technique. And the next thing is multi-phase sampling technique. Phase wise, I want to do some kind of the one kind of health education procedure to thousands of people in my first phase. Second phase, I want to do some advanced thing. So I select a particular population for advancement as my second phase of the studies, third phase of the study. And for each phase, I can have a different sampling technique. So multi-stage, multi-step, and multi-phase technique. Multi-phase and multi-stage technique are almost same. Multi-step, usually we use geographically, or sometimes within an institute, we may use the college or institute in the university, then the class, and within the class like that. That would be a multi-step sampling technique. And the when we go directly to the simple random sampling, then we go stratified. And after stratification, go for a systematic or a simple random again. For all this, you need to determine sample size. I think we'll be using the AP info, the sampling table solution. Sampling table is given. It takes only 1 or 2 minutes so that you can know that how to use it. The I will show you which manual you're supposed to use. This stat calc you should be using for considering sampling technique. Right? And if you are doing a survey in the population, for example, I'm not going to detail, but just going indicating that this is what you can use the sampling sample size. Your population is 10,000. You don't know your expected frequency, how many are sick, how many are not sick. Take it 50%. Margin of error 5%, that's 0.05. Now the design effect, remember, this design effect, when you are going to do, for example, first a state and then within a state, a district, within district, a taluka, if you go like this, then, or if you take a stratified sampling, so either you do stratification or you go for multi-step technique, then design effect will be there. If you're directly taking, let's say, from whole population, is only one. But if you divide into 10 parts, and then that is your next thing, for out of 10, which two, and then you doing further within that strata, then design effects two. If you do further go into for taluka, for example, you have taken a state, then further you're going for district, then effect three, like this. So if you take directly from the all district of India and further from the districts, so if you have chosen a district and then directly from that sample, then design effect two. If you take directly from the country, randomly from whole 140 crore population, there is only one design. But if you divide into district, then you take from each district, design effect two. If you take further from the taluka, design effect three, like this. So look at the sample size over here is 324. If you write down design effect three, you can see there is increase in sample size automatically. If you take 10% over here, you can see the sample size is decreasing over here. If I take 50, some increase. Instead of 5% margin, if I take 1%, huge increase in sample size if I want to reduce my error. If more error is allowable, need small sample size. So from whole population or from you have, let's say, 1 lakh patients flow in a year, you want to take out of that, then 1 lakh population of the patient will be over here. This is how you can calculate sample size from where you want to study the population survey. That out of 1 lakh population, 1 lakh patients, how many are satisfied? That if you want to find out, this is how you can use it. So I end my something on the sample over here. But next time I request all of you to share your topics, which topic you're going to do, what is your population defined, what is your sample size, which sampling technique you're going to use, that you should be sharing the group. That will make it the more interesting. Forum is open for the questions. I will stop sharing the screen. And any question
Sir, good evening,
or
sir.
any, yeah, good evening.
Sir, one doubt, sir. In this app, EPI Info, sir, we are taking
Hmm,
the population size is around 10,000, no, for example.
hmm,
If I want to do my study in my hospital, for example, in anesthesia, in comparing one method to other method,
hmm.
what should I do, enter in this population size, sir?
So in this
Population
case,
column.
you are not doing population survey. You want to
Okay,
do a
sir.
cross-section survey or you want to do a case control study, unmatched for example, then you can take this kind of study. That power usually you can go for, let's say, the 90% power of the study, and then the ratio control and cases maybe 1 to 1 ratio you can have, right? And then personal controls exposed, let's say 20%, like this, and odds ratio approximately, right? You can
Okay.
write odds ratio could be 3, like this, or I am writing 33. So that based on assumption, how much is going to be your case in control or one group and second group, based on that, it will show the sample size over here. So I have a very simple formula for you people to find out, because without this also you can have a simple size calculation with a simple formula that the n is equal to 4pq, right? N is equal to 4pq upon L square. 4 PQ upon L square. L square is most difficult to understand. L square is allowable margin. How much the margin you want to have it? That is the L. You want to have a range of 10%, 5%, P and Q. So P is percentage having some particular characteristic. Q is not having characteristic. So N is equal to 4PQ. Usually, if you take P and Q 50-50%, that will give you the highest number of sample size. So 50 into 50 is 2,500. Multiply by 4, that will give you the 10,000. But L square, you want to have the percentage difference, the range. Suppose if you want to have a result between 49% to 50%, your range is only 2%. But if you want to have range 45 to 55, that much range you want to have, you have 10% range, you will have automatically less sample size. So if you, how much samples, the difference you want to have, that is basically two standard error. L is nothing but a two standard error. That much error, if you want to have it, that you should decide in your the study that how accurate result you want to have, and based on that you can have a sample size. So usually the sample size is calculated by the statistician because it is not always simple. So the formula n is equal to 4pq divided by L square. L square. Square I will not be able to write down like this. How do I write square? Square. Right? This is a formula. But when you say we want to compare two groups, automatically n is equal to, it will be the P1, Q1 upon N1, P2, Q2 upon N2. That N1, N2, you need to bring it out. And that's why it differs, right? So in case of standard of differential to mean, you go for the formula of standard error and you need to bring out. So that's why usually people say that let's session do it, but you should remember that if you are doing a large study, usually 400 sample is sufficient. If you are a clinician, if you want to take a number of patients, 100 patient two group will be sufficient. If it is a problematic, you can get 30-30. You are dealing with a rare patient, you can go for non-parametric test and you can go for 20 or 13 patient in each group or 10 patient and 8 patient also. Right, sir. Formula not visible. I need to just, I not, I will be sending to everyone. N is equal to 4PQ divided by L square. Now it is visible. I forgot to send to all. So sample size will differ as per your study design. Whether it's a cross-section study, whether it's a population-based study. Suppose you, based on a sample, you want to talk about population. Which point? You want to talk about some the numeric or number or let's say quantitative or qualitative. Accordingly, the sample size differ. So
Sir,
based on, yeah, please.
sir, I have also one doubt.
Hmm.
What would be the sample size if I want to on that population survey, or if I want to calculate that evaluation of risk factor for morbidity and mortality in
Hmm.
pediatric population 6 months, from 6 months to 9 years presenting with LRTI. In that case,
Hmm.
what would be the population size? If I want to sample size, what would be the sample size if I want to calculate it?
So, when you do the research study, what is your population? Tell me that first. Then we'll talk about the sample
Yes,
size.
sir. Evaluation of risk factor.
Huh?
Evaluation of risk factor for morbidity and mortality.
Risk factor in pediatric
Yes,
age
sir.
group,
six
right?
months to 9 years presenting with LRTI.
But that 6 months to 9 years, you would like to go and find from the population or from
No, sir. In a
OPD patient.
tertiary care hospital, sir, where I used to work. in that hospital, if I want to get it, go for the risk factor for morbidity and mortality in terms of in the OPD patients, sir.
So OPD. So how much? How first you should know in your OPD population approximately how much OPD population you have
Doctor sir,
of that age
approximately
group
200, sir, per day.
daily or
Daily,
per year,
daily, sir.
daily too. So you how many days you would like to do the study?
Uh,
Say, see,
Sir,
for
suppose I have,
example,
we have 2 days in a week OPD. In my unit, we have 2 days in a week.
so you want to carry out the study for whole year, or 2 months or 3 months, because that will define your population.
Okay, but it will depend upon that.
So
Yeah,
once you define your population, see, first you decide your topic. It's good that you have decided your topic very well. Now the next thing is when you publish your research paper, you are going to have some you are going to extrapolate to some population. Now your OPD patients are coming from all over. So you define that I'm not going to work in the community. I want to work in the hospital, and my population is to the children between 6 months to 9 years coming to my OPD for 1 year, for 6 months, 3 months, that you need to decide. Then you should have an approximate idea that how much is that population, 5,000, 2,000, 3,000, something like that. Now, when you take a sample of, let's say, 100, 200, or 300 children, you would be extrapolated to this 3,000 children. Or it may be possible that you may include all the 3,000 population. If you are going to include all this 3,000 population, there is no question of sampling. But if you want to take a sample, let's say a 10%, 20% of this population, then the question arises how much sample size should be there. And to decide that sample size, you want to find out the risk factor. So the final condition, this risk factor is this. To associate this, you first need to decide which kind of data analysis you are going to do. Will it be logistic regression analysis? Then it will be a different thing. Or if you are going to do simple thing, risk factor present, risk factor absent, what is the outcome? Now,
yeah,
when you are doing this kind of analysis, you remember that patient are coming to you, and then you have three things to compare: a disease condition, other than that disease, but some disease there, and no disease condition. But no disease people are not coming to your OPD unless you take well baby center also, where the children are without illness. So this kind of the thinking should go first, and then you can decide about the sample size. To decide sample size, suppose you have taken a particular sample, 100 or 200 like this.